In this video, I am going to use the fundamental theorem of calculus part 2 to find the definite integral from 0 to pi over 3 for secant theta and tangent theta. Now let's go ahead and look at my f of theta, okay, which is secant theta times tangent theta. And as you know, this is nothing but 1 over cosine of theta times sine of theta over cosine of theta. So now we just need to ensure that in the interval that we are integrating over, which is from 0 to pi over 3, in this interval, this function is continuous. Cosine of theta is in the denominator, so we just need to ensure that it doesn't evaluate to 0. So in the interval 0 to pi over 3, cosine of theta is non-zero, meaning that the denominator will not be 0. So this function is continuous. So f of theta continuous on the interval 0 to pi over 3. So by the fundamental theorem of calculus part 2, we know that there exists antiderivative, okay, for f of theta, which is going to be antiderivative, let's call it f of theta, okay. Now this integral can be evaluated pretty easily. Once we find the antiderivative f of theta, we just evaluate it at pi over 3 and subtract from it the evaluated value of f at 0. Now, as you probably know, derivative of secant theta is secant theta times tangent of theta. So my f of theta is nothing but secant of theta. Okay, it's very simple, straightforward. I need to evaluate this f of theta at pi over 3, okay, which is gonna be secant pi over 3, but secant pi over 3 is 1 over cosine pi over 3. So cosine pi over 3 is 1/2, I believe, right? So 1 divided by 1/2, which is 2. So this value is gonna be 2 minus. Now I need to evaluate it at f of theta is equal to 0. Cosine 0 is 1. So this is just going to be 1 over cosine of 0, which is 1, just 1. So 2 minus 1, which is just 1. Very simple. So this integral evaluates to this value. It's not necessarily the exact value that really I'm concerned about. I want you to follow the process. I gave you a very, very simple example, okay? And I want you to follow the steps by ensuring that, in the interval where we are integrating over, the function is continuous, find the antiderivative, and then use the fundamental theorem of calculus part 2 to evaluate that integral by using FTC, or fundamental theorem of calculus part 2, and by evaluating the values of antiderivative at pi over 3 and at 0. I hope that this discussion was helpful. Thank you very much.